Well, welcome to second semester of Math 152. Actually, just Math 152, which is taught during the second semester. So I'm going to put multiple problems on each recording. So we're going to do 21, 24, and 27 for section 7.1. And basically what these are equations that need to be solved for the unknown. So I'm just going to write these down. So we need to is find out the value of x where these equations are true. And back in the days of SOLs, you probably could have used your calculator to find out the solution without actually solving this algebraically, but I don't do multiple choice questions on tests, so you're going to have to learn this if you haven't learned it in the first place. So the first thing you do is you'll notice that we have terms that involve x. So we got like this term which is 2 times x. So we have 2 x values here. If we multiply this out, this is called using the distributive property. And what it means is if you have a number outside of parentheses, you take that number 3 and you multiply each term in the parentheses by that number. So let's just go ahead and do that first. So if you have any terms like this where you have a parenthesis and a term out in front of the parenthesis, then you take this number and multiply each term. And that's just because that's just a short way of showing that well, let's go one step and I'll explain it. So if you multiply 3 by x, you get 3x. If you multiply 3 by -4, you get -12. We'll put our equal sign there, so we're finished with that part. On the right-hand side, we have 2 times x, which is 2x. And we have 2 times -3, which is -6. Okay, so what we've done here, actually, in the original statement is we have rewritten this as that. And why do we do that? Because there's a common factor between these two terms, the common factor being 3, because this is multiplied by 3 explicitly, and 3 times 4 is 12. So we can rewrite that in a simplified form as 3 times the quantity x minus 4. So if I multiply this back out, I get to this point. So these are the same, represent the same quantities. And we did the same thing here. 2x minus 6, we do what we call factor out of 2, because there's a common factor. We have 2, which is the term multiplying by the number of times we have x, and we have 6 is 3 times 2. So we can factor out the 2 and rewrite that as such. So when we are trying to solve for x, we have to go back and put it in its less simplified form, because at this point we're going to combine like terms on either side of the equal sign. So this is what we call simplification. So we're going to take the terms that involve x and combine those. So if you have 2 x's and you add 3 x's to them, you're going to end up with 5 x's. So what we do is we basically just add the coefficient, the constant in front of the x terms, and then multiply that addition of those of 2 and 3 times 5. And because what 2x represents is really x plus x, and 3x represents x plus x plus x. So when you add these all together, 1, 2, 3, 4, 5, you get 5. Okay, so we simplify that by combining like terms. In this case, on the left-hand side of the equal sign, we only have one constant term. The constant term is a term that is not multiplied by a variable. So we just leave it as -12 because there's nothing to do. And on the right-hand side, they're already simplified or combined because there's only a constant term and there's only a variable term. So that's the first step, is you want to get something times x and then plus or minus a constant equals something times x plus or minus constant. Now, the next thing we're going to do is we are going to what we call moving all the terms involving x to one side and all the terms involving the constant to the other side. And when you move these things, basically what we're doing is we have like a balance. And so here's our fulcrum, and this thing is balanced there. And if you have, let's say, -12 value here, to keep this thing balanced, we could add 12 to both sides. Because if you have something balanced and you do the same thing to both sides, you add the same amount, you subtract the same amount, you multiply the whole side by a constant, then the thing remains in balance. And what we're doing by adding 12 to both sides is when you add 12 to the -12, you get 0, and you basically eliminate the constant from the left-hand side, but keep the equation still balanced. So what we can do is we can add 12. So this step here is not part of the original equation, but it's how we're going to modify the equation while still keeping it balanced. So we're putting 12 units of something on the left-hand side, 12 units on the right-hand side. Therefore, the thing is balanced because you're doing the same things. Like if you have, if you had a balanced seesaw and you put the same weight on one side as on the other, this thing would stay balanced. And then we perform the operation. So what we're doing now is we're just adding the left-hand sides and the right-hand sides together. So when you add 5x to basically 0x, we don't usually write that down, but basically if I wanted to include each term and include the terms that are 0 or not there by putting a coefficient 0 in front, I can do that. The reason I do that is just so you can see when I do this operation, when I say 5x plus 0x is 5x. You see what's happening. Another way of saying it is just I'm bringing the 5x down, but what I'm really doing is adding it to 0x. I'm adding each term. Here I have -12 plus 12, which is going to give me 0. Then I have 2x plus 0x is 2x. And then I have -6 plus 12, which is positive 6. Now, you can, well, let's go ahead and leave the zeros in there. You don't need to, but so what I have now is I've simplified it because I don't have any constants on the left-hand side of the equation. The second thing you want to do is you want to get this term, you want to take this term and somehow eliminate it from the right-hand side. So to eliminate it from the right-hand side, we're going to have to subtract it. But to keep the equation balanced, we also have to subtract it from the right-hand side. So we can't just say, let's get rid of it, because if it'd be like somebody on a seesaw, if you lifted somebody off a seesaw, it's going to become unbalanced. So the only way you can get rid of one thing is to subtract it from the other side. So remove it the same amount from both sides. Now, again, we implicitly, which means we don't show it, but it's there, we implicitly have this term 0. In this second part, the part that we're using to keep this original equation balanced, but by removing this term from the right-hand side and adding the appropriate amount to the other side. So we subtract 2x from both sides. Okay, so you do that. 5x minus 2x is you do the math associated with the coefficients, and 5 minus 2 is 3, so you get 3x is equal to, well, 2x minus 2x is 0x, which is 0. So let's not. So what I'm going to do is this. I'm going to do it the long way, and then I'm going to just do it the short way here. So here we have 5x minus 2x is 3x. 0 plus 0 is 0. 2x minus 2x is 0x. 6 plus 0 is 6. Okay. Now, what we can do here is we can simplify this by getting rid of terms that involve 0 or 0 times something. So this becomes 3x is equal to 6. Finally, we want to solve for x. So again, to keep something balanced, if you had, again, let's use the analogy of the, let's say you had 3 pounds of something over here, and you had 3 pounds of something over there, and they're equal distances from the point where it's trying to balance. If this is true, then if I divide this by 3, and I divide this by 3, then this still remains balanced, obviously in this case, because there's 1 pound here and there's 1 pound there. So we can do the same thing here. If we divide both sides of the equation by the same constant, then this equation remains balanced. So we can take this and we're going to divide by 3 specifically so that we only have x remaining on the left-hand side. So 3 divided by 3 is 1. So we get 1x is equal to 6 divided by 3, which is 2. And just like here, when we had zeros, we could drop those. We can't drop the 1, but if we don't have the 1 in front, it's implied there's only 1x. And there's your solution. Okay. 2x, x equals 2 is a solution. And if you go back and you plug it into the original equation, you can check to see whether that works or not. So if you take the answer you get and you do the math, so what I've done is for x I put in the solution, which I got x equals 2. So we have 2 times 2, which is 4. Plus 3 times 2 minus 4 is negative 2 is equal to 2 times 2 minus 3, which is negative 1. So you get 4. 3 times negative 2 is negative 6. 2 times negative 1 is negative 2. 4 minus 6 is negative 2. That equals negative 2. Check. Negative 2 equals negative 2. That verifies that this is the solution to the equation. X equals 2 is the solution. Okay, so I've done it the very long way. How would you do this? Well, we would do everything the same until we get to this point. 5x minus 12 is equal to 2x minus 6. And instead of doing these two operations one at a time, what we would do is we would add 12 to both sides to solve for x over on the left-hand side. And then we would also subtract 2x to eliminate the variable part from the right-hand side. And then you would add the columns together. 5x minus 2x is 3x. 5 minus 2 is 3. Negative 12 plus 12 is 0. Now, I'm not going to put 0 because 0, once you do this and you get 0, you can just kind of say, don't have to worry about it anymore. 2x minus 2x is 0. So I just don't write anything down. Negative 6 minus 12 is negative 6 is positive. Negative 6 plus 12 is 6. And then I could divide both sides by 3. And I get the answers 2. And so that would be the shortest version you could do to get the solution. Okay, so that's 21. 24. Negative 2x minus 3 times 4 minus 2x. Am I writing this down right? Is equal to 2 times x minus 3 plus 2. Okay. So, same kind of thing. First thing you're going to do is we're going to go back one step, unsimplify these by multiplying the term in front of the parentheses by each term in the parentheses. The ones that don't involve parentheses we just write down. So negative 2x just is copied. Negative 3 times 4 is negative 12. Negative 3 times negative 2 is positive 6. And then you have the x. So negative 3 times negative 2x is positive 6x. A lot of people do the first one correctly, and then they do the second one incorrectly, especially when there are negative signs involved. So be very careful. On the right-hand side, we have 2 times x, which is 2x. 2 times negative 3, which is negative 6. And then we copy down the 2, which is not. Okay, so that's first step. Unsimplify by multiplying each parenthetical expression by the constant or the term in front. Second step, combine like terms. So which are like terms? Well, we have a negative 2x and a positive 6x. These are like terms because they both involve a constant times x. So to combine these two terms, we take 6 and we subtract 2, or we take negative 2 and add 6. Either case, you get positive 4. So negative 2 plus 6 or 6 minus 2 are both 4. There's only one constant term, so we don't have to do anything there except just copy it down. In the right-hand side, we only have one term that involves x, so that we just copy down. Then we have two terms that involve constants, so we do the math. Negative 6 plus 2, or 2 minus 6, that's going to be negative 4. Remember, what we have here is we start at negative 6. That's the first number in the number line. You add 2, which means you move to the right on the number line. So that means you're moving closer to 0, and so you get negative 4. Or, if you think about it the other way, we switch the order of these, which you can do. So if we looked at 2, so that's our starting number. So what we're doing is 2 minus 6 instead of negative 6 plus 2. You start at 2. The negative means you move to the left on the number line. 1, 2, 3, 4, 5, 6. You end up at the same location just by, you end up with the same answer. So whether you have negative 6 plus 2 or 2 minus 6, you get an answer of negative 4. Okay, so that's combining like terms. The next thing to do is to add and subtract stuff, same thing from both sides. Now the things we're going to add and subtract, we're going to subtract 2x because I have positive 2x on the right-hand side, and I want that to go to 0. So to make that to go to 0, I have to subtract the same quantity. 2x minus 2x, that'll go to 0. I have to do the same thing to both sides to keep the equation balanced. Likewise here, I have negative 12. I want the left-hand side not to include any constant terms. So to eliminate negative 12, I have to add 12. And to keep the equation balanced, I have to add it to both sides. So I'm going to subtract 2x from both sides. I'm going to add 12 to both sides. And then I'm going to do my column addition or subtraction. 4 minus 2 is 2. Negative 12 plus 12 is 0. I'm going to go ahead and write it down this time. Just 2 minus 2 is 0x. Negative 4 plus 12 is positive 8. So that's 2x equals 8. Divide both sides by 2 to solve for x. I get 1x is equal to 4, or x is equal to 4. And now for the final problem in this sequence of 3 is 27. So I'm going to write this out. So basically all the same problems, are just a little bit additional level of complexity. And while I'm writing this down, I'm just going to make a comment. This section is labeled linear equations. And I don't think that's exactly correct, because these linear equations are equations where you can draw a line x versus y, or y versus x. And there's no y involved in here, so I'm really not sure why they call it linear equations. We'll get that to the next group. Okay, so here we go. So again, you can see we have two terms involved, parentheses. So the first step, as we always do, is we're going to multiply the term in front of the parentheses by each term inside the parentheses, being careful about making sure that if we have a negative sign here and a negative sign in here, that we do it appropriately. So the first two terms don't change during the first step, so we're unsimplifying it. So we have negative 5 times x, which just gives us negative 5x. We have negative 5 times negative 1. 5 times 1 is 5. But because there are two negatives, we get positive 5. So this becomes that. On the right-hand side, we have this negative sign in front. And really what we have is negative 1. But just like we don't write 1x here, we don't write negative 1 times, we just have the negative sign out in front. So what that means is negative 1 times each one of those. Or you can think that whatever's in here, I'm going to change the sign up. So I'm going to have 2x, change the sign, that becomes negative 2x. Have negative 4, change the sign, it becomes positive 4. And then the last two terms are copied them down and changed. So again, these two parenthetical terms become unsimplified, become separate terms. And then we combine like terms, which in this case we have x-like terms and constant-like terms on both sides. So we're going to have negative 3x minus 5. So what we have is negative 3, that's where we start, and we go another negative 5, which means we go this direction. So we're more of a distance from 0. So that's going to be negative 8. So negative 5 minus 5 is negative 8x. 6 plus 5 is 11. Negative 2x minus 5x is negative 7x. Again, we start at negative 2. We go to the left on the number line, 5 units. 4 plus 5 is 9. So that's simplification, combining like terms. Okay, so we're at this point. Now what we're going to do is we want to solve for x. So we want to take the term involving x on the right-hand side and eliminate that. So to do that, we have to add the opposite sign of this. So we have negative 7x, so we're going to add 7x. We have to do that to both sides to balance things out. And then we look at the constant. In this case, we have 11. So to eliminate 11 from the left-hand side, we have to subtract 11. But to keep the equation balanced, we have to subtract 11 from both sides. Then we do the column addition. Negative 8 plus 7 is going to be negative 1. So we get negative 1x. This goes to 0. This goes to 0x. 9 minus 2 is negative 9 minus 11 is negative 2. So we get negative x is equal to negative 2. So to solve for x, we need to get this as a positive x. So we divide by -1. Divide by -1. So we divide both sides by the same number. -1x divided by -1 is +1. -2 divided by -1 is +2. So we get x is equal to 2. And we didn't do it on the last problem, but if I take this solution, x equals 2, and I plug it into the original equation, I should get the same number on both sides. So I'll get -3 times x plus 6 minus 5 times, actually +2, yeah, +2. Oh, I said 2 minus 1, so that's the left-hand side of the equation, the original equation. So I've got -3 times 2 plus 6 minus 5 times 2 minus 1. Okay. Then I have -2 times x, which is 2, minus 4 minus 5 times 2 plus 5. Okay. 2 times 3 is 6 with a negative sign. So you get -6 plus 6. -5 times 2 minus 1 is 1. Here I have -4. 2 times 2 is 4. Subtract 4 minus 5 times 2. 5 times 2 is 10 plus 5. So this becomes -6. This is just copied down. This is -5 times +1. Okay, so these -6 plus 6 is 0. So I get -5 on the left-hand side. -5 times 1 is -5. This is 0. So this goes to 0. Then I have -10 plus 5. And -10 plus 5 is -5. And there I go. Same thing on both sides, so that is the solution, correct solution.